This is section 1.1, understanding points, lines, and planes. Just so you know, at any point in this video, you can pause, stop, rewind the video at any time, just in case I'm going too fast. The objectives, there's two. First one is identify, name, and draw points, lines, segments, rays, and planes. Second one is apply basic facts about points, lines, and planes. Next slide is the vocabulary. By the end of this lesson, you should be familiar with the following terms: undefined term, line, collinear, segment, ray, postulate, point, plane, coplanar, endpoint, and opposite rays. Next slide, let me just read this to you. The most basic figures in geometry are undefined terms, which cannot be defined by using other figures. The undefined terms that we'll be using in this course are point, line, and plane. Next slide talks about those terms. Let me show you. This is what we call a point. Use a dot to represent a point. Notice it right next to it. It's a P, so this is the name of this point. In the same manner, this is a line. Notice the arrows on both ends, 2 points. This is how we can name this line. With the 2 letters, you can switch it around. Notice that on top of the 2 letters, there's a line with arrows on both ends. Or you can also name this line by using this lowercase letter that is right next to it. Plane, this is how a plane looks like. This is how you can name it. Notice that there's a scripted capital letter, so we can name this plane R, whatever this is. And also we can name this plane by using these 3 points, but these 3 points have to be, they cannot be on the same line. Points that lie on the same line are collinear. So in this case, these 3 points are collinear, K, L, and M. K, L, and N are non-collinear because this point is not on this line. And then points that lie on the same plane are coplanar. Next slide. Practice. Using this figure, they want you to name 4 coplanar points. This is the answer. A, B, C, D. The bottom portion of this is a plane. Part B says name 3 lines. There's different possible answers. The one that I'm going to show you is this. And notice that I'm using the capital letters to represent the points. And on top of the 2 letters, I have a line with arrows on both ends. Same thing for the other 2. This is actually definitions. I'm not going to read this definition, but this definition is describing this diagram. This is what we call a segment. The way that we can name this segment is right here, AB and BA, or BA. Notice that on top of the 2 capital letters, there's no arrows, because now is representing a segment, is now representing a line. This is the definition of endpoint. If you look at this diagram, C and D are endpoints. Read the definition of ray. This is a ray, RS. Same thing, RS. And notice that the way that we can name this ray is by looking at the 2 capital letters. The points are S. And notice that on top of the R, there's no arrow, because there's no arrow on either of these 2 rays. And then on top of the S, there's an arrow, because it goes through S. It doesn't stop here at S. The last part is definition is opposite rays. This is illustrating opposite rays. Read the definition, it should make sense. It says draw and label each of the following. They want you to draw a segment with endpoints M and N. That one's really easy. This is an answer to part A. Part B says opposite rays with a common endpoint, T. So this is what we can draw. Opposite rays, common endpoint, T. Draw and label a ray with endpoint M that contains N. This is how we can, this is the drawing that we can use to represent part C. Next slide. I'll read this. A postulate or axiom is a statement that is accepted as true without proof. Postulates about points, lines, and planes help describe geometric properties, and we're going to be using a lot of postulates in this course. Eventually, we cannot do this. We're going to have to prove whatever we're using. We're no longer going to call it postulate. We're going to call it something else. But anyway, these are the three postulates that we'll start using. This is postulate 111. Through any 2 points, there's exactly one line. Illustration. Postulate 112. Through any 3 non-collinear points, there's exactly one plane containing them. Here's an illustration. 113. If 2 points lie in the plane, then the line containing those points lies in the plane. It's pretty straightforward. Look at the illustration. If you want to clarify any of these, talk to me in class. Next slide says practice. Name a line that passes through 2 points. So we want to name this line. So what will be the name of this line? XY. You can also do YX, but notice that there's arrows on top of the capital letters. This is describing a line. Number 3 says name a plane that contains 3 non-collinear points. There's 2 possible answers. We can use the 3 non-collinear points to describe this plane, G, H, F, or you can use this scripted capital letter R. More postulates. If 2 lines intersect, then they intersect in exactly 1 point. If you think about it, this makes perfect sense. Postulate 115, if 2 planes intersect, then they intersect in exactly 1 line. We'll be using that eventually towards the end of this lesson. So in this case, for practice, I want you to sketch 2 lines intersecting in exactly 1 point, which is basically describing 1, 1. And I'll draw for 114. This is easy. This satisfies problem number 4. Problem number 5 says sketch a figure that shows a line that lies in a plane. So we want a line, but it has to be in a plane. This drawing satisfies number 5. Next slide. It says sketch a figure that shows 2 lines intersecting in sketch a figure that shows 2 lines intersect in 1 point in a plane, but only one of the lines lies in the plane. So this is a little bit tricky, but look at this drawing. 2 lines that intersect, but this line only intersects the plane, this yellow plane, at exactly 1 point. This is like a, I don't know, like a knife going through this yellow plane, and it only crosses the plane at this point. This is the last portion of this lesson. More practice. They want you to name 2 opposite rays. By looking at this drawing, you have CB and CD. Notice that on top of the C, there's no arrow in both cases, but on top of the B and the D, arrows appear. Number 8, a point on ray BC. This is describing the ray. Possible answer is D. What will be another answer? Point C. Another answer, point B. 9, the intersection of plane N and plane T. Here's plane N going up and down. Plane T almost horizontal. So we want the intersection of these 2 planes, which is line BD. And if you recall, this is describing postulate 115. This is the last problem from this section. A plane containing E, D, and B, the only plane that satisfies the conditions of number 10, plenty. And we are done with this lesson.